Welcome to this video. I'm going to be doing another AP Precalculus free response question. This is no calculator allowed. I believe this is in one of the old revisions of the AP Precalculus course description before they updated it for the class now. Okay, but this looks like a question that covers all the topics that are in the AP Precalc course. So I'm going to do it as for you guys to see the solution, because I don't see a solution actually in the document. And of course, it's good practice for you guys too, if you have not seen this problem before. So pause the video first if you haven't done this before, and then unpause it to see me solve it. Okay, I actually have solved these, pre-solved them. So I'm going to go over my solutions. Okay, so this says the functions above, all these guys, are defined for values in their respective domains. So part A, solve the following equations for x, show the work that leads to your answers. By the way, there's no scoring guidelines for these, so I have no idea how they're going to score it, but I'm going to show you my work that leads to the solution. Okay, so first of all, they ask us to solve for x when f of x is equal to pi over 3. So that's when 3 to the x plus 4 is equal to pi over 3. Then it tells us the solution should involve a logarithmic expression. Okay, so that's what I did over here. So 3 to x plus 4, that's our f. I set it equal to pi over 3. How do we solve an exponential equation? We use the log. So I did log base 3 on both sides. That's this line right here. And when we do log base 3 of 3 to the x plus 4, well, first of all, why did I choose log base 3? Because this base of the exponent is 3. So things will cancel because they're inverses. Okay, so log base 3 of 3 to x plus 4, this x plus 4 remains because log base 3 and 3 to the x are inverses, but we have 3 to x plus 4, so we are left with x plus 4 on this side. And then log base 3 of pi over 3, we can't really simplify, so we leave it as that. So x is equal to, I move the 4 to the other side, log base 3 of pi over 3 minus 4, and this is my answer. This should be good enough. They don't say that you have to use log base 10 or natural log, so log base 3 should be okay. Okay, so next, similarly, g of x is pi over 3. So they want us to solve inverse cosine of x over 3 equals pi over 3, or arc cosine. I like saying arc cosine instead. Okay, so that's what I wrote over here. Arc cosine x over 3 is pi over 3. So I took the cosine on both sides. When I take the cosine of inverse cosine, they're inverses, so we're left with the argument, x over 3. Okay, and then we have cosine of pi over 3 on this side. I didn't evaluate this quite yet, I did at the end, but to solve for x, we just move 3 to the other side by multiplying. So x is equal to 3 cosine of pi over 3. Cosine of pi over 3 is half. Okay, so x is equal to 3 times half, which is 3 over 2. As simple as that. Next, it says to rewrite the expressions below as follows. Show the work that leads to your answers. We write h as a single expression involving the natural log of a single expression for values of x for which both expressions are defined. Okay, so basically this for values of x blah blah blah, that's saying just state the domain probably. Okay, so what did I do? This, they asked us to write h. So I first rewrote it as half times ln of x plus 3 plus ln of x minus 3. I moved the half out in front instead. Same thing. Okay? I can use properties of logs. When we have a sum of two different logs of the same base, then the arguments can be multiplied, and then we can combine it into one log. Okay? So it's like ln of a plus ln of b is equal to ln of a times b. So that's what I did over here. And x plus 3, x minus 3, we can rewrite as x squared minus 9. Okay? I'm not sure if this is actually needed, but I just did it. Okay? And then we can use the other property that when we have a coefficient out in front, we can bring it inside as an exponent. So usually the simplification is when we have a power, we can bring it out in front. But we're going to go the other way. We have something out in front, we're going to bring it back as a power. So like this. Okay? And then since it's x squared minus 9 to the half power, I can rewrite it as square root of x squared minus 9 inside the log. So I would write this, I would have this as my answer, and then we got to worry about the domain. So in the original guy, this or this is the same thing, right? Technically, this is the same thing too, but let's look from the original. The inside of the log has to be greater than 0 in order for it to be defined. So in this first one, x has to be greater than -3 in order for this log to be defined. And over here, x has to be greater than 3 in order for the log to be defined. Okay, so this one is precedent because this requires that x be bigger than 3. If this one only requires x be greater than -3. So for example, if x is 0, this would be fine, but this would not be fine because we have ln of -3. We can't do that. So this takes precedence. X has to be greater than 3. Okay, so that's that. But let's also check over here, since we rewrote the expression. So inside the square root, it has to be greater than or equal to 0, but the argument of the log has to be greater than 0. So inside the square root, we can just simply say, say that is x squared minus 9 is greater than 0. Not greater than or equal to, because if it's equal to, then it'll be ln of 0. So that doesn't work, as I said. So x squared minus 9 is greater than 0. That means x has to be greater than 3. Okay? Again, the -3 would, because when we solve the quadratic, it'll be -3 also, but then from the original, it doesn't work, right? So we just say x is greater than 3. Okay, so then it also asks us to rewrite k as a single expression involving only sine x and no other trig functions. Okay, so we have cosine times cotangent. Cosine times cotangent. So I left cosine the same. Cotangent I wrote as cosine over sine. Okay, and then I combined the two cosines. Cosine times cosine, that's cosine squared. Okay, and they asked us to write it in terms of sine. So we're going to use the identity sine squared plus cosine squared is equal to 1. So that means cosine squared is 1 minus sine squared. Okay, so this is the simplified expression, but we have to worry about the domain. Okay, so even from the original, sine x cannot be equal to 0. We'll be divided by 0. So same thing here. So I'm not sure if this is acceptable by the AP graders. Technically, I would think it's fine, but let's be a little more specific. If sine x cannot be equal to 0, then x cannot be 0, plus or minus pi, plus or minus 2 pi, so on and so forth. Because remember, sine x has an infinite number of solutions. For example, if x is 0, sine x is equal to 0. When x is pi, sine of pi is also 0. 2 pi, sine of 2 pi is also 0. And even in the negatives, okay? So we can write it like this, 0 plus or minus pi, plus or minus 2 pi, dot, dot, dot. But to be a little more neat, we can just say x cannot be n pi, where n is an integer. Okay, so I think this is the best answer, but this might work in itself, so I don't know how to grade it. Okay, but just explaining the process. Okay, and then last one, m of x, solve m of x is equal to square root 2 for x. Express the solutions in numeric values not involving a trig function. If possible, show the work that leads to your answers. Okay. So where did I do that? I did that over here. M of x is equal to square root 2. So that means 2 sine 3x is equal to square root 2. We solve for x. Okay, so how do we solve this trig function? First divide by 2 on both sides. And then remember, when we have like sine of something that's not just x or like not theta, it's not just that single variable. In this case, it's 3x. So let's make a substitution. Let's let u be equal to 3x, for example. So sine of u would be square root 2 over 2. There's an infinite amount of solutions, so they don't restrict the domain here. So we got to account for all the solutions. So u can be pi over 4 plus 2 pi n, where n is an integer. Okay, so in the unit circle, when u is pi over 4, then sine of pi over 4 is root 2 over 2. Okay, and similarly, when u is 3 pi over 4, then sine of 3 pi over 4 is root 2 over 2 also. That's in quadrant 2. Okay, and then if you go another 360 degrees, it's a coterminal angle, so it's the same angle, same position, so that's why it's 2 plus 2 pi n, where n is an integer. So plus or minus 2 pi, a full revolution, either in the clockwise or anti-clockwise direction. Okay, so this is our solutions for u, the infinite amount of solutions. So we want x though. So we back substitute u as 3x. That's what I did over here. 3x is pi over 4 plus 2 pi n. 3x is 3 pi over 4 plus 2 pi n. And then we solve for x from here. So we divide by 3 on both sides. Got to be careful. So x is pi over 12, because 4 times 3 is 12, so 12 on the bottom, plus 2 over 3 pi n. And then over here is pi over 4 plus 2 over 3 pi n, where n is an integer again. So infinite amount of solutions. And this makes sense because the frequency increased, or the period decreased. So you should have more solutions within each revolution. Okay, and that's how I solved this problem. Hopefully this was good practice for you, and hopefully my solutions have helped you if you got stuck or you got something wrong and wanted some clarification. Okay, as always, please like and subscribe if you found this helpful, and I'll see you in the next video, hopefully. Bye.